Okay, the first thing is to understand that essentially, right, M is just the foot of perpendicular. Okay, so yeah. Let's see how we can do this. M is foot perpendicular. All right, so what we need to find is what is M? So we try and figure out what does this mean? BM, where's BM? A to B, A, B, C, B, C, F, G. Okay, great. So this, now take note of this. Please take note here to here. Okay. Now what we need is essentially this short, this is M here, right? I'm not sure where's the, it may be somewhere else. I'm not sure. It doesn't have to be that point there. So this is M here. Actually, if I have A, B, C, they want the shortest distance of M to the rectangular base, right? The shortest distance will just be actually the C, this C here. This C will give you the height of M. That's the shortest distance, what? Right? That's the shortest distance. So since you want to use the previous way of this will be the height, maybe height, or yeah, that's the height that you need to find. Since you want to use the previous one, so meaning to say you just find the coordinate of M. That's the main thing. You need to find the coordinate of M. But how do you find the coordinate of M? That is the annoying thing, because now you need to see whether this is an acute angle or that or this is actually acute or obtuse. If it's obtuse, meaning the normal is pointing downwards. If it's acute, meaning the normal is pointing upwards. Okay, so I repeat, because now you're using A to B, right? And then after which you A to B is here, and after which you dot N, N is here, right? Actually, you should use B to A. Sorry. If you take B to A and dot at, and because I'm assuming N is pointing upwards, if this gives me a positive dot product, meaning it is acute. If dot this, meaning to say, just look at the dot product here. It is obtuse. Okay, so this is actually quite important. So I will repeat again. You try and take B to A instead of A to B, because now the angle is important. I repeat, so what I'm going to do is I'm going to take B to A, because I drew B to A, right, on the diagram. This is B to A. This is B, this is A here. So draw B to A is here. Use exactly B to A would be minus 800. Then normal, I'm assuming, is pointing outwards, so it's 201, right? So this case here, actually what happens is if you take A to B dot with 201, this would be minus 200 dot with 201. This is actually negative 16. Negative 16 meaning to say it's actually obtuse, no longer obtuse. It's actually this angle here. So actually this normal is pointing downwards. I repeat, this normal is pointing downwards. Okay. Now, why this is important? Because if you do not know where is it pointing, you can't possibly find the length there. Okay. Obtuse. So this one is like that. Okay. So this is important. Okay. This part is going to be confusing. Okay. This part is going to, no. You're supposed to use part 4. You're not this is the only method you can get the marks, okay? Because of the phrasing, right? This is the only method. There's no other way you can do it really. This is only, if you do anything other than this, right, meaning you don't get the marks. Because the part is use your answer in part 4. If you never use the answer in part 4, you can't. Okay? Meaning to say you need to use this one, somehow use this length here. Okay? Okay, I'll explain again. Mr. Gan, could you explain again? Okay, Kate. I understand this part here is confusing. So start off with I'm going to explain again this part because this is confusing. Let me explain again. okay, we have a plane here. Okay, let me explain. We have a plane here, and then this part here, we have a B, and we have a A. Now, part 4, we know that this distance here, this M is what we want to find. We know that this distance here is 16 over root 5. Take note of that. So in other words, right? Okay, let me tell you what you should do. You should actually do B, this direction here. So you want to find OM, right? Now you want to find OM. So if you want to find OM, what you could do is you just find AM. So OM is actually OM is actually OA plus AM. Agree? Secondary school stuff. Now, OA, we already know what is it. Okay? AM is actually 16 over root 5 times unit vector of AM, A to M. Okay? This unit vector here. We need to take a unit vector. Unit vector is direct proportion. So we need to take like one unit vector. Okay? Now this one unit vector, how to get? The question is how to get this unit vector. This unit vector here, we can take the normal lah. Okay? The normal. The normal. So, but the question now is the normal pointing outwards or the normal pointing downwards? That is the question. Okay? Because without knowing the direction, you do not know whether you should add or you should minus. That is the problem. Okay? So, I repeat, you want to use the unit vector of the normal, but you do not know whether the normal is pointing upwards or pointing downwards. That is the question. Okay? So, my proposition is very simple. To know whether it's pointing upwards or pointing downwards, simply just take BA, which is actually BA, not AB. I use AB here. So use BA, meaning to say 800 here. Okay, this is 800, this direction. And you assume that, okay, then you just take BA 00, you dot with the normal. The normal usually you assume is on top, correct? So this is 201. Is it correct? 201. BA is minus 88. BA is minus 800. And this will give you minus 16. Okay, because this is cosine. This meaning cosine theta is 0, meaning to say it's actually an obtuse angle. If it's obtuse, right? Okay. If it's obtuse, the normal is not converging with the back direction because this is acute, meaning to say the normal is actually pointing downwards. Okay. You need to decide the normal pointing downwards by doing a dot product without modulus, because if it's negative, it will tell you it's obtuse. That is the first thing you need to do. So, is that okay? If not okay, review this video again, okay? Because we really don't have much time. So once you do that already, you take the length of 16 over root 5, you times the unit vector of, okay, so we know that this is actually n, right, is parallel to AM. It's actually pointing downwards, okay? So this will just be the AM, the unit vector of AM is equals to n unit vector because they are parallel. Any parallel vectors, the unit vector, the chop off one unit is exactly the same unit that you are looking at. So in other words, this would just be 2 unit vectors is 201 over square root 2 square plus 0 square plus 1 square. So this will be 201 over 5. So this OA, what's OA? OA is actually we want to find AM, right? A to M. A to M. Or A. OA is minus 4 minus 20. Okay. Plus 16 over 5, 201. So this one would probably be, my goodness, this is not fun. Minus 4. Okay, so this one is, okay. So OM is 16 over 5. OM is 16 over 5. In other words, I could find my H of OM is 16 over 5. So the height Z coordinate is the okay, that's it.